All right, welcome everybody. Week 14, day 3. We're going to finally get to inheritance, which is a huge, huge topic. It's as big and kind of hard to wrap your brain around as pointers in classes. But I think if you have a professor that can explain it well, you can get it fairly easily. Okay. But just be warned, it's not going to be that easy. You know, it's going to hurt your brain a little bit. So just work hard at it. Practice. Ask questions. If you were taking this class in Java, they usually start with inheritance. Whereas inheritance is usually the very last thing that I teach in the 2 semesters of learning to program. So ES2 is dope. Yeah, Endless Phase 2 is a surprisingly good game. I've been having a lot of fun playing it. Okay, so let's go over classes again. So let's make a file here called inheritance.cc. See if my macro still works. Cool. Look at that. Remember the macro that I set up last time? Neat. Still there. So let's say I want to make a hash table class. Oh wait, we've already done this. So let me go over the syntax for inheritance first, without even like motivating it. I'm just going to show you guys the syntax for it and what it means, and then I'll give you guys the motivation afterwards, because I think I've already kind of motivated it for you. Like, if you guys remember your hash table assignment, I told you there's inheritance in it. In the code that I gave you, there's inheritance, and for you to just like not worry about the syntax and stuff like that in it. Like here, I've got a hash table pointer. And this hash table pointer points at nothing by default. Here, it's not initialized to anything. It's not even initialized to null, technically. Probably that null pointer or something. I don't know. Yeah. But basically, based on the user input, it can choose to become either a linear probing hash table or a chaining hash table. And the reason why this magic works, because normally you can't have a pointer of one thing pointing at a pointer of another thing. Like you can cast it, I guess, but it doesn't work. The reason why this magic here works, where I'm setting table, which is of type hash table, and it's getting set to be a pointer of linear probing hash. The reason why this works is because linear probing hash is using inheritance. It's a subclass of hash, which is the superclass. This is the parent class, this is the child class. And by doing this, then down here, I don't have to make 2 different variables, one variable of type linear probing hash, one variable of type chaining hash, not. Instead, once I get this out of the way, all the code down here just refers to table. Table insert, table remove, table change. And because linear probing hash and chaining hash both have functions for change and search and insert and remove, it works. And it works nicely and beautifully. Just remember to delete your thing that you allocated at the end. Okay. So, inheritance. So, let's go over the syntax. Class. They always use animals when doing examples for inheritance. I don't really like that. I'll just make it more abstract. Class A. No, I'll just make it a struct. Make it super basic. Struct A. It's got a function called print name. I really don't like these examples. They're so basic. Whatever. Print. Cout. I am a... what's the word? Invictus. There. I am the master of my fate. I am the captain of my soul. There we go. All right. finish off the struct like that. Now, this should be pretty straightforward to you guys. I can make a variable down here named named Bob, and say bob.print. And what will this print to the screen? So I've made a variable named Bob of type A. Everybody of type A has a function called print, and that function will print out I'm the master of my fate, captain of my soul. So when I call bob.print, what is this going to print to the screen? Did I get the DLC for ES2? I did. That's why I have the soundtracks. I bought all the DLC, which accidentally included the soundtracks. Soundtracks are pretty good though. Yeah, it was not cheap. I went on to GTG to get some Steam keys that way, but it worked out to about $60 for the DLC. Yeah. It's a really good game though. It will print the string. Fine. Couldn't get you guys to type out I'm the master of my fate, I'm the captain of my soul. Fine. Okay. Struct B inherits from A. So I read that in English. What does it mean? Copy and paste everything from A to us here in B. Here. So if I make a variable named B named Sydney, I can call Sydney.print. And what is this going to print to the screen? And why are you complaining at me? I forgot the semicolon. Thank you. Semicolon. I always forget it. Why don't you need a semicolon? You need a semicolon. So what is this going to print for Sydney? Same as A. Okay, so that's inheritance. That's it. All right. So that's it for today, guys. Can you chain inheritance as much as you want? Sure, let's do it. Struct C inherits from B. Notice the syntax here. Colon here means inherits from. And then you give it a form of inheritance. 99% of the time you're going to use what's called public inheritance, where it just copies and pastes everything over. If you do private inheritance, it copies it over, but you can't use it. So it's kind of weird. Now, there's more to lecture on today, but I do want to say that at 4 p.m. today to 5:30 p.m. Irish Music Workshop. If you can't make it, submit a two. Can't make the workshop today, then watch it at your leisure and submit a 2-page essay on Canvas stating what you learned from the workshop. Okay, so yeah, we'll get into virtual in a second, and we'll talk about the difference between private and public in a second. But the question was, can you chain inheritance? The answer is yeah. So, okay, so if I make C called Pablo, what is Pablo going to print? It's polymorphism, inheritance, and virtual the same. They're all related to inheritance. Let's put it that way. It's called a grandchild. Yeah, so this is the parent class. This is the child class. This is the grandchild class. Yeah, so this will print the same thing. So far, so good. C copies and pastes everything from inside of B. B copies and pastes everything from inside of A. So C has a function called print. Okay. Now what if we overrode that? What if we said, wait, what happened here? Okay. What if we said void print cout, oh captain, my captain. What happens then? We got two functions, same name, print both. Let's find out. So, if you override a function, this replaces this one. This one no longer exists. Instead, it is a completely different function. It doesn't have to see out something. It could be like a for loop or something. It doesn't matter. It replaces the earlier one with a new version. And then you saw that C got this version as well. Because remember, it copies and pastes everything from B. So everything inside of C is just copied and pasted in. Okay. Make sense? So whenever you inherit a function, if you don't do anything with it, you just get it. You can inherit variables as well. Int x equals 10. So x is a member variable. It's initialized to 10. We have a function here called printx that prints x. And down here in C, C copies everything out of B, B copies everything out of A. We didn't override x or printx, so when we call Pablo.printx, it prints 10. Okay. That makes sense to you guys? That's what inheritance does. Just a way of saving yourself a little bit of copy and pasting. Okay. Technically, we could do this, right? That works fine. The variable is declared in A. The print function is in B. C gets everything from B. B gets everything from A. So it all works. It's all good. Okay. So, still works exactly the same. Of course, you can't call it on A now, right? So if you tried calling bob.printx, this would not compile, right? Because printx is not a member of A. Right, you guys see that? I moved printx to here, so you can't call it on A. Inheritance can work on both class and struct. Classes and structs are the same thing. They're literally the same thing. They compile exactly the same way. The only difference is structs default to public and classes default to private. Okay. And inheritance is for classes. Yeah, there's other kinds of polymorphism as well. For example, when you overload a function, so you have two different functions with the same name, that's a form of polymorphism. Usually when people talk about polymorphism, they talk about inheritance. Okay, so, okay. So far, so good? Not too bad, I don't think. All right, so yeah. So let's say we had a function. Void foo, it takes a also named Bob, just keep things simple, and it's going to call bob.print. So rather than having bob.print called here, I'm just going to call foo bob. Do you guys see that? It's going to do the same thing, right? I pass a up here. By value, it makes a copy of it. Then it calls Bob's print. When fiddling around with templates, you have to apply that template type name T part to all the classes, yes. Yeah. More or less copy and paste that template thing all over the place. If I run it, you see it's exactly the same. No surprises? I pass Bob to a function named foo, and it calls bob.print. Does the exact same thing as before, right? Okay. Now, rather than calling Sydney.print, we're going to call foo Sydney. So we're going to pass Sydney to foo, and then it's going to call print. Let's call this variable something different because it's not going to be Bob. Whatever. I can't come up with variable names right now. I have not had enough coffee. Okay. So will this code compile? Can you pass a variable of type B when it is expecting a variable of type A? Is this allowed? And the answer is yes. You can tell because it didn't throw a compiler warning here. But when you've got a subclass can be passed to any function that takes the superclass. That's one of the reasons why we do inheritance. It cuts down on having to copy and paste code. So if this function printx here was there, then we can call printx that. And then because B is guaranteed to have a print or a printx, right, because it copies and pastes it, we can pass a B to this, and it's going to call print and printx on B. Okay. And so naturally, it's going to do the exact same thing, right? Oh, wait, it didn't. Rather than printing, "Oh, Captain, my Captain," it printed, "I am the master of my fate. I am the captain of my soul." What the hell just happened here? Told you, it can get a little tricky. What the hell just happened here? Well, let's say that we, I don't know, have a constructor here for B, and it sets x equal to negative 9,000. So is it just converting Sydney to an A? Like, what's going on here? Well, no, it's still Sydney, right? Because the value is negative 9,000. So when I call print x, it is printing the value of x, and the value of x is in fact set to 9,000. So it is of type B. But when I call print, it calls A's print, not B's print. And the reason for that is because C++ by default doesn't know if this is inherited or not. It will assume that it is the base class. So this is something called slicing. When a subclass loses what makes it special. Okay. So if you do it this way, what happens is that the compiler just looks at this and goes like, yeah, that's an A, and so I'm going to call A's print and A's printx. Now, as it turns out, B has updated its value, but it's calling these functions here. Okay, it's an optimization thing. So still doesn't work, but now it works. Okay, doesn't work anymore. What the hell is virtual? So virtual is a way of saying the virtual keyword. This is a learning point for today. And then so this will inherit from A. That's what we talked about earlier. That's one of your learning points. Second learning point for today is the virtual keyword. And so what the virtual keyword does is anytime you have a pointer or a reference, because a reference is just a pointer that looks nicer, what it does is it says, okay, I know I'm supposed to be an A. I really know I'm supposed to be an A. But am I? Am I really? Let's find out. And so what C++ secretly does is it saves within the class what type it is. I'm actually an A. I'm actually a B. I'm actually a C. And so what happens is when you call a function that is marked as virtual, it inserts an if statement in there. And it says, if I am A, print this line. Else, if I am B, print this line. Okay? You guys understand? So virtual, every time it's equivalent to doing something like this. Constant type equals A B Alfred Noy's poetry, if any of you are familiar with The Highwayman. It's a pretty brutal poem, by the way. Like I read it to my daughter and I teared up reading it to her. It's a brutal, brutal poem. Lorena McKennitt turned it into a very beautiful song. Pretty good adaptation too, I would say. When you do virtual, it's basically something like this. Like if we didn't want to use virtual, we could do something like this. Like if my type is A, do that. Else if my type is B, else if my type is C. This is literally what the virtual keyword does for you. So it creates what's called a V table, a virtual table. But this is effectively what you would have to do if you don't have inheritance. This is how you do it in SeaWorld. At SeaWorld, there's no inheritance. So you can just add a member variable to a struct. They do have structs. You just add a member variable saying, I'm an A, I'm a B, I'm a C. And then, every time you call print, you have an if statement. Say, if I'm an A, do this one. And if I'm a B, do this one. If I'm a C, do this one. And that's how you do inheritance in C. Okay. So, is the same thing in Java? I don't know what that means. Is the same thing. So in Java, you don't need virtual. Java actually figures out automatically, because everything in Java is a pointer. It just doesn't look like it. But every object, not primitives, but like any object you create, every class type you create is automatically a pointer. And so every time you call something on a pointer in Java, they're automatically virtual. Java is designed to be inheritance-based from the ground up. So you don't have to use the virtual keyword on it. But so this is basically how it would work. And go back and put it the original way. You'll see. That's where my failing codes. What happened here? Foo. I'm not calling foo. Okay. Foo. Okay, so because it makes a copy. Yeah. Yeah. So when you make it virtual, then it does it. If you don't have virtual in there, then it will hard code it to be A, and only the A version works. Okay, so when you have virtual, it basically, it'll pick the right function for you. Okay. All right, so but basically this is how you do it in SeaWorld without that. We don't need that though because we are using virtual. Okay. So the virtual keyword will insert basically that if statement for you, right? Switch or whatever. And so you don't need to write down what type you are, although oftentimes you do anyway, because a lot of times you want to know. But when you have a virtual function like this, then everybody that inherits from it, it's virtual also. You don't have to put virtual here if you don't want to. Instead, it's good practice to do this override, which comes after. And override means I'm overriding a virtual function. You don't need it. If you don't have it there, it doesn't do anything. It's just purely a safety measure, right? Like what if I came up here and changed this to be capital P print? Then you see how this throws a compiler error now, because I'm overriding my parent's thing, and my parent changed his name, and so now I'm not actually overriding anybody. So override is just there to prevent you from not overriding something. If you give the override keyword, it must override a virtual function from the parent above it. And so if the parent above it changes that, or oh, this is a const class, watch this. It's now a const method. Bloop. Override now throws a compiler error. It will not compile. Why? Because it is not actually overriding this guy anymore. Because that's a different function signature. Right? So if we were to compile this, you'll see it doesn't override anything. And you look at it and you're like, look, it's called print, it's called print. That's actually a different function signature. So the CV qualifier is part of the signature. And so so if you put an override here, then it will throw an error saying, hey, you're not overriding anybody. You should be careful about that. So if I put the const there, then it works. You might ask, does it have to be const override? Can it be override const? Has to be const override. Okay, I guess. Okay. So basically when you're doing inheritance, you're going to mark your stuff as virtual. The most important thing to mark as virtual is your destructor. If you don't have a virtual destructor, it'll only call the destructor on the base class, and it won't call it on the subclasses. So anything you have down here, like if you've got a, I don't know, you got a vector events or something, dot size 9,000. Like if you got a vector events, resize. If you got a vector events of size 9,000, the destructor on A is not gonna kill it. Okay. So you need to have a destructor for A, even if it doesn't do anything. You mark it as virtual. Another learning point. Always make a virtual destructor. If you don't do that, it only calls the destructor on the parent class, not on the subclass, and you could feasibly leak memory and stuff like that. So the compilers will oftentimes tell you to make it virtual destructor. Save that. I've seen it before, trust me. Okay. Yeah, I'm gonna do that. Okay. If I want to print A and add on to it the print B, okay. So if you want B to call A, okay. So yeah, very common to call the parents thing. So you can do A : print. And so now when you call B's print calls A's print, then prints out, oh, captain, my captain. And notice how it did not print out the highwayman came riding. You see that? For C, it did not print out the highwayman came riding. Why? Because we changed this to be a const method. You see? It just bit us in the ass. Right? So we need to make this override at a minimum, and then it will tell us, hey, by the way, you're not actually overriding anybody. You thought you were, you're not. Psych. So there. And if we fix that, then you'll see that that's A. B prints out A's print, and then C does its own thing. Override is incredibly useful. Nah, override's useless. If you write your code well, you don't need it at all. For checking yourself, yeah, sure. Or you can just be like me and just don't make any mistakes when coding. In CSci 45 this year, one of my students, Dolia, was having trouble getting his code to work. He was getting negative timings. And so I just log in as him and run it, and it works fine. He's like, what? What? I'm like, I don't know, man. I don't know. I just can't make code not work right. Yeah, so this is for constant method. We're not returning a constant type. This is where you put constant method. And so void print const is the signature. Void print const is the signature. You could put virtual here if you want. It's not. Oh, it doesn't do anything. It's already marked as virtual in the V table. Okay. Yeah, if you put a const here, this would be returning a constant void, which is not doable. You can't return a constant void. But if you have like const enter or something like that, then that would mean the int you're returning is a constant. So the const comes here to indicate it's a const method. It's the only place it could go, basically. Right? It looks weird having a spot between the function name and the function body, but that's the only place it can go. So that's where those things go. Yeah. So let's talk about public protected and public. So let's say we made this private, made this public. as we're supposed to do, right? All of our member variables are supposed to be private. Does not compile. A : x, that's the scope resolution operator, right? That means A's x is private within this context. Private. Remember, who can access your private members? Only yourself and your friends. Okay? Not even your kids can access it, right? So, B is a child of A. It cannot access A's privates. Okay? If you want to do that, you can't have it be a private. A private member is just not allowed. You need to use a new keyword here called protected. Protection. If you don't use protection, that's how you get kids. Okay. So protected is like private, except protected is like private, except your kids can access it too. And so by default, don't use private ever. By default, if you're going to be doing anything with inheritance, don't use private ever. Use protected instead. There's almost never a good reason for a variable to be private, because if you've got some variable here inside of A, you've got a subclass, and that subclass, I don't know, down here is doing something with that variable that you've got in the class, it won't compile if it's private. Both protected, just signed. What happened?
Bazikian actually brings forth an interesting question that I'd never thought about. If it's protected, can friends still see it?
Yeah.
Okay.
Yeah. When you make a friend, like let's say we're down here inside of foo. Let's make it real simple. Let's try adding 1 to that guy's x value, right? Won't work. Why? It's protected. Just like private. The only difference between private and protected is that protected variables can be seen by the kids as well. So you need to use get and set, etc., etc. But if we were to declare somebody as like a friend, right? Say friend void foo, like that. Then let's just copy that whole thing. So if we're to make foo a friend, now I can access it. Okay, so friend grants full permissions to some other function or to some other class. And so you do it like that, and now it can read and write to the private, protected, either way, variables. Okay. You guys understand? This is in general considered bad coding practice, right? To read and just have some function reading and writing to the variables. I mean, if you got to do it, you got to do it. But in general, I wouldn't. I would write a getter and a setter, and but maybe my class shouldn't have a getter and setter. I don't know. Then yeah, maybe you do this. I don't know. It's a big, complicated world out there. But proper class design, your member variables are protected, and you have getters and setters out in public. And so if foo needs to get the value of x, call get x. That's fine. Yeah, you can't grant partial friend privileges. It's either a friend or it's not. So you can't make it so they can like read from it but not write from it. If you want to do that, then you can make like a get function but not a set function or something like that. Okay. And if you really need fine-grained control, you could grant friend privileges on another class and have that class have read access but not write access, or have a get function but not a write function, no set function. So there's clever ways of setting up that kind of stuff. Usually it doesn't matter too much. When do you see friends? From your experience, when do you see friends? I saw them a lot more before the pandemic, that's for sure. But now that I'm vaccinated, I'm kind of, able. Like I'm having friends coming over on Sunday for the first time 6 months. I don't know. When do you use friends? Yeah, to seriously answer your question, the only time in recent memory I've used friend is with OStream, because it's the only way you can get it to work, right? So you would be like friend OStream at operator double left arrow, right? Remember this, OStream at outs const a by reference, whatever, and then right. You guys remember that? The only way to overload the double left arrow operator is by using a friend function, because otherwise you'd have to be modifying the OStream class to have a operator that takes this as the right hand side. Can't do it. So that's honestly the only time in recent memory I've used friend. In general, I have a get method, I have a set method, and I just use those to read and write to private variables. It's kind of, yeah, but if it's there for you if you need it. Right. So maybe if I was going to be writing a less than operator, and right, like if I was to write like bool operator less than taking in an int, let's not use that. Why? Now my class can be compared against an integer, right? But only on the right hand side. So you could right now, like you could say if foo is less than 5, see out hi. Right, this code would work now. So if foo is an a, right? Because you've defined a less than operator that takes a on the right hand side and a int on the right, an a on the left hand side, and it takes an int on the right hand side. However, this code will not work if 5 is less than foo. Nope. That doesn't work, because when you have code that's like that, it calls the member function on this class, calling the operator less than. If you want it to work both ways, and some of you guys might have seen on the imaginary homework, it only works one way but on the other way. If you want it to work both ways, you need a friend function, right? So you need friend operator less than, taking in a int y on one side and a const a named something on the other side. I'm just beyond trying to come up with good variable names now. Friend bool answer. Return y is less than. Okay. So that would be another case. Like if you wanted this to work, it's a less than operator that takes an int on the left side and a on the right side. If you want that to work, you can't modify the int class, because int isn't even a class. You can't add a member function like this to it. Instead, you have to use a friend or global. But friend's probably a better way of doing it, because this doesn't exist in global space somewhere. It's just part of the class, right? Essentially. But it allows you to do it where you've got an int on the left side and a on the right side, like that. And you might be like, wait, do I have to do this for less than and greater than and less than or equal to and greater than or equal to in both ways, and with constness and without constness, and yeah. So that's why the spaceship operator is around now, right? So you can now say, auto operator spaceship versus an int. And that will generate less than, greater than, less than or equal to, greater than or equal to. Doesn't do equals and not equals. I learned that recently. It's a bizarre design decision. It only does the 4 basic ones, but in various degrees of constness and stuff like that. So you also have to do you also have to do the double equals operator. However, if you use the default, this kills me, operator, if you use the default one like this, versus, if you use the default one, it'll generate double equals for you. The hell, dude. So if you set it equal to equals default, it does all 6 comparisons. But if you do it manually, it only does 4 of them, and you've got to use double. Yeah, I'm like, the hell? Why would you do that? That is this weirdest language design. And somebody said there's some sort of optimization that enables, like, if you're comparing vectors, then you want it to terminate early if they're not equal or something like that. Whereas, right, like if you're comparing two vectors, the first time you find one that's not equal, you just return false. They're not, if you're doing comparison, right? Double equals. The first time you find an element that's not the same, bail out, quit. Whereas if you're doing this operation, you would have to go through the entire thing and see if it's greater than or less than or equal to. And so that's why they split it like that, was to enable, I don't know, some sort of optimization, although in that case I'd probably just specialize it myself. I don't know. You're almost sore after the Pfizer dose. Soreness went up to your neck. Get your second dose tomorrow. Oof, good luck. I had my second dose and had no side effects. I mean, partly it's probably because I have superior health and nutrition. Sorry, can't keep a straight face when saying that. But level 100 immune system. Nah, it's if I really thought about it, I might have been achy or something like that. But I tend to abuse my body pretty badly, rowing and lifting weights and stuff like that. So my body's usually hurting somewhere, from that. And so I couldn't really tell if it was due to the shot or due to the exercise. So, it's funny. Kearney Jong-un, yes. I am, was it Team America? I'm bigger, stronger, more physically fit. Yeah. Yeah. So good luck on the second shot. I do hope all of you guys get vaccinated, though. The sooner everybody gets vaccinated, the sooner we can go back into person. Hopefully, it's looking like we might be back in person in the fall. So, are any of you guys planning on taking 26 in the fall? Kim Jong-il, yeah. Yeah, good. So maybe we can actually see each other. Yeah, that's cool. Like, I've had you guys for an entire year, and I don't know what almost any of you look like. I know Muya. It's a shame. Emma. See if you can take a IS-50 over the summer. Get some more experience. I did run into one of my students at a fencing. I've enrolled my daughter in fencing classes at the Fresno Fencing Academy. And a student came up to me and was like, "Are you Professor Kearney?" "Yeah, I'm in your class." I'm like, "Oh." I don't know anyone's face. It's all just names and Discord. So, yeah, even if you transfer to Fresno State, Blancas, you can still take classes with me if you want. It's a thing. In fact, Fresno State sends students over to me fairly often. Like if their discrete math fills up, they send people over to me to take them, because I'm kind of a dummy. I tend to just add everybody, so maybe I shouldn't. But up to like the fire marshal threshold, I guess. All right, so okay. Wow, you look nothing like your Discord profile pic. It's got like an anime character or something. Okay, so inheritance. So protected there. Learning point. Numero trace, use protected instead of private when doing inheritance. Now you might be wondering about this thing here. Like, what if we switch that to private? Can't do it. Okay. So this thing is protected, and so normally we would be able to access it down here in B, right? We would normally be able to access it. However, if you do private inheritance, then it lowers everything that was public in A becomes private in B. And there's reasons, I guess, to do it, but I've only had to do it maybe, I don't know, never. Because you can't call anything on it, right? Like, you can't call print. You can't call anything on it, right? So it's still a child, and you could like pass it to things that take an A. But none of the things in A you can access. They're all private. They're still there. They're taking up memory. You just can't access them. And so it's a really niche kind of thing. And so, given how useful public is, and how more or less pointless private inheritance is, there is niche uses, but I'm just going to say it's pretty much pointless. What do you think that means? That's inheritance. B is inheriting from A. Do you think it is public inheritance or private inheritance? And if you do protected inheritance, then public things become protected. Which, again, not very useful, because usually whatever you have in your public interface, you want to keep it public. Yeah, so unfortunately, no, that is not public inheritance. This is private inheritance. This is the same thing as writing private A. C++, here's a quote. C++ is a language where all of the defaults are wrong. Right? It's literally, and I think Bjarne's kind of acknowledged that fact. He made a decision back in like 1979 or something, and we're stuck with it today. Because if we were to change it, it would break everybody. Right? So, like if I delete protected here, what access level is this? X is now what? By default, a struct is what? A struct, Bazookian. What default is a struct by default? What access is a struct by default? Public, right? So, what if this was a class?
By default.
By default. By default.
I mean, but you can't even make it private anyway.
Huh? Yeah,
you can't.
You sure can.
Private.
Yeah.
Yeah?
Yeah, sure. This is fine.
I have never even tried that.
Sure. Yeah. The only difference between a struct and a class is the default privacy setting. That's it.
I thought it was just like it could only be public. Why do we even use classes then? Structs are just better.
Because I don't know. The reason why you think that, Muya, is because whenever I use a struct, I'm designing it in pod style, right? Plain old data style.
Right.
It's just a bunch of public variables and maybe some member functions with them. You will pretty much never see me use private with a struct, because that means I'm using proper class design. If I'm using proper class design, I'm going to be doing a class, and again, double quotes on it because there's nothing wrong with using a struct, right? And then I do it this way, right? Why is there a difference between struct and class? There's no good reason for it. It could just all be structs. But to me and to other professional programmers, when we look at this line right here, will you?
Yeah.
When you look at this line, that's a clue to us. Is this thing plain old data or is it an ADT? That makes sense?
Yeah.
So if I see the word class, I expect it to be an ADT. If I see the word struct, I expect it to be plain old data. Or plain old data structure. So it's just a clue to people, like what you're gonna do. Anyway, so the problem with class is that it defaults to private instead of protected. So there's almost no reason to use private. Yeah, if you're going to be subclassing off of a class, I can't think of any risk factors in giving them access to your private variables. You know, and so in all honesty, classes should default to protected inheritance, and private inheritance should just be like some niche case that like it's there if you want to like look it up and you need it or something like that, you can Google it. And like I said down here, like if you just do inheritance without any access specifier, it should be public inheritance, because that's 99% of all inheritance in C++. It's public inheritance. But nope, C++ is a language where all of the defaults are wrong, right? So you gotta do it that way. Is he muted? Can you guys hear me? The thing that can get confusing for me is I think the amount of functions being overridden or inherited. Yeah, it can get confusing. And so you might have heard Mulia said earlier, like, I don't use inheritance. And that's like mostly true. Like you saw in the hash table assignment, like I used it because it made sense, right? And if it makes sense, then I'll use it. Like I'm not a hater, you know. If there's a good reason for it, I use it. And the trouble is, when I took this class in 1995 and 1996, this was right when Java was being written. Java was the C++ killer. It was all object-oriented. Everything's inherited in Java. Literally, in Java, you've got ints and floats and doubles and bools, chars. Like, you got a very few set of primitive types. Literally everything else in Java is not only a class, but it's a class that inherits from another class. Literally everything in Java is inheritance. There is one superclass that everything ultimately derives from. That's called object, capital O object. And they put a ton of stuff into the object class, like a hash function, and serialize and things like that, that all these, you know, every class you make inherits from by default, and you can override. And that's sort of the product of the 90s having this fascination with object-oriented programming, building these big class hierarchies. I'm going to make an animal class, and then the subclass of the animal class is going to be a mammal class, and then I'm going to make a subclass of the mammal class for dogs and cats and people. And then there's going to be a bird subclass of the animal class, and there's going to be a reptile subclass, and they create these giant class hierarchies. And then you try making a function, and it's like, all right, let's say I want to make a function that says maybe every animal has an attack, right? Like I'm making a video game. Every animal has an attack. Okay. In fact, let's just move inheritance to inherited old .cc, and let's just do this, right? Class animal, and damage. I'll do 10 damage by default, and then public And this has to be in the protected section. And then we're going to have a bite. Every animal has 100 health by default. And then void die. Yeah. Oof. Owie. Embed. So every animal has the ability to die. Every animal has the ability to bite. And bite. You can pass in another animal to it, and animal A will bite animal B. And so we'll say other dot health minus equals 10. If other dot health is less than or equal to 0, other dot die. Okay. You guys with me so far? So I can make animal SpongeBob. Maybe we can void animal int new damage. Okay, so we're gonna make a SpongeBob. SpongeBob has an attack of 2 and a health of 1,000. And we've got animal squirrel that has an attack of 100 and a health of 30. While what's wrong here? What's it complaining about? Right, not void. Sorry. Okay, while sponge, and then we're gonna need getters and setters, and get health. Get health. And get damage. Damage. Health. New health. Void set damage. Alright, so while SpongeBob dot health is greater than or equal to 1, or just say greater than 0, see out. What's the name of the squirrel in SpongeBob? It's like the astronaut. Sandy. Sandy attacks. Okay, so while SpongeBob has health, we're going to print out Sandy attacks SpongeBob, And we're going to damage him. So Sandy.bite SpongeBob. Yeah. SpongeBob has SpongeBob.get health. Alright, little combat routine here. SpongeBob not declared. That's a ignore return value. So I'm casting it to void, dude. What is it? So annoying. I don't care about the return value of the system. You're supposed to cast it to void.
Just turn off W unused result.
No, I know, but it's just like the way you turn it off without turning it off is you cast the return value to void. Can you look up how to do that, will you?
Yeah.
It's static cast to void. Let's see if that'll shut it up. No, still annoying. Yeah, supposedly casting it to void turns off the unused result value warning. But I don't know. I'm probably doing something wrong.
They're just doing what you did.
Right? So.
Like, they just cast it to void exactly. They were doing the implicit cast.
Yeah. I don't know.
It's weird. C++ 17 now provides the maybe unused attribute. So it's like the it's basically the double open, yeah, maybe underscore unused.
Come on, there we go. Maybe unused. What's the syntax on it?
It's exactly how you typed it.
Cannot be applied to a statement.
A line above. Let me see if it says.
Cannot be applied to a statement.
Oh.
Or I can catch the return value, right? But now it'll be like, okay, fine. A lot of times it'll just complain X is unused. You're setting X, but you're not doing anything with it. Right? All right. So there we go. All right.
Oh
so,
yeah, it's for unused variables, not unused return values. That's why. Yes, that would apply to the X.
Excellent. All right. So Sandy is attacking SpongeBob. You can see she is slowly draining his health. And oof, owie, I'm dead. SpongeBob has 0 health left. Okay. So we've got here a little, like we're making an RPG or something. We got a little combat system going on. All right. So this is fine as it is. Now, let's say that I am my professor back in the day. And he's like, no. You should not use the same type if they're different types. You need to do inheritance. So we're going to have to inherit off of this. So we're going to have a class called mammal that inherits from animal. We're going to have a class called squirrel that inherits from mammal. We're going to have a class called sponge. What is SpongeBob? Man, I know that sponges are not mammals, but like, I mean, he's a sponge, right? He acts like he has a spine sometimes. I'm just going to have him inherit from mammal too, and if you want to have your biology professor write me an angry letter, I will accept it. I will take that one. Okay. Yeah, sponges are their own entire phyla, I believe. Phylum Porifera. Porifera. Cool. All right. I don't care. This is SpongeBob. All right. So now we're going to have a SpongeBob. We're going to have a squirrel named Sandy. No matching constructor for the initialization of Sponge. Versatile. All right, so for the Sponge class, we will create a Sponge constructor that also takes in int new damage equals 10, int new health equals 100. And it's going to call the parent class. It's actually going to call animal, passing in new damage and new health. Let's see if that works. Doesn't like that. Let's see. Animal is not a direct or virtual base of Sponge. Cool. Maybe that's what the problem is. No. Yeah. Okay, so welcome to the world of inheritance. It sucks. So we've got a SpongeBob that is taking 2 and 1,000, and it's actually going to call its parents constructor. Its parents constructor is going to pass those 2 variables up to its parents constructor, and its parents constructor is going to set damage to be new damage and health to be new health. This is what you do. If you've got some variables in a parent class and some variables in your grandparent class and some variables in your class, you initialize your variables, you pass the remaining ones onto your parent. The parent does their thing and then initializes the ones on their parent, and you chain together constructors this way. Okay, that's why that shortcut notation I told you is actually really important. It's more than just a shortcut. This is how you have, like, if the mammal has, I don't know, how much hair they have, then maybe we'll just initialize hair to be, doesn't matter. The point is that Sponge is responsible for initializing everything that is Sponge specific. Then you call the parents constructor, and then that initializes anything that's the parent specific. Then it calls its parents constructor, and that, do you understand? So you chain together constructors that way. It's kind of annoying. This, for example, doesn't work, so we have to do the same thing with a squirrel constructor. Squirrel int new. I'll just copy and paste this. All right. And we're back running again. So, and if you think this is annoying, this is not nearly as complicated as class hierarchies get. Right? There's going to be an animal class, and then out of that there's going to be birds and mammals and reptiles, and out of the birds there's going to be pigeons and geese and emus and eagles, something like that. So, yeah. These class hierarchies get really big and really complicated. And in my opinion, it's not worth it most of the time. Sometimes it is. Like I said, like I'll use inheritance like when there's a good reason for it. Like if I'm going to be duplicating a lot of code and I need all the stuff in a parent class to be copied into both of the kid classes, yeah, I'll do it. Sure. And so if you just look at these things like root class, vehicle, and this is somebody just demonstrating how it works, but vehicle, there's land vehicles and water vehicles, and then land vehicles, there's a bike class and a car class and a truck class and a submarine class, a sailboat class. I actively dislike doing it this way. Actively. Right? So watch this. Let's say that we want sponges to do double damage against squirrels. All right, so we're going to have Sandy attacking SpongeBob, and then we're going to have SpongeBob, I don't know, makes a Krabby Patty. Sandy. So you notice how I can write either, I spell it right. Do you notice how I can use both SpongeBob get health and Sandy get health, even though they're different classes, because they both inherit from a parent class. They both have a health and they both have a get health function on them. By using inheritance, I don't have to copy and paste code between classes. If you're finding yourself having to copy and paste giant chunks of code between two related classes, it's probably going to be better to refactor it so you inherit off a common class and that code gets copied and pasted for free. Then there's only one place where you need to update it. Okay. Can an animal call bite on itself? I don't see why not. A wolf that has its leg trapped will chew its own leg off to escape. You can have, sure, you can have SpongeBob bite SpongeBob. Yeah, I don't see why not. Okay, so we got a little conflict going on here. And so SpongeBob takes out Sandy pretty quickly. Right? He's a giant tank. Sponge, 2 damage at a time, is that right? Is that actually working? I don't think so. Sandy has 10. How is that not? How is that not passing the data in? Yeah, whatever. So, here's the question though. What if you wanted to make it so that sponges do double damage against squirrels? So you come up here, and you're like, all right, we have one animal biting another animal, all right? Well, how do we tell what type the animal is? All right? Can't. There's no way of knowing what type that animal is. C++ knows because it has a virtual table set up. And in fact, there's ways you can do something like this. Like you could have a void byte that takes a sponge on one side and a squirrel on the other side and have it do double damage. But then you've got to make a function for every combination of every animal you have in the game. So if you've got 100 animals, you got to make 10,000 different functions to handle all the different ways they can damage each other. Right? I think it's called a visitor pattern or something like that. And it's kind of garbage because you have to write n squared functions when I really just want to have like an if statement saying like if, or have a table, right? Fire type does double damage against plant type, right? And so what people constantly do when they're doing inheritance is they'll cheat, right? They'll come back and they'll say string class name equals animal, and they just write down inside of the class, I am a animal. My class name is mammal, right? My class name is squirrel. My class name is sponge. Right? And then what they'll do is say if my class name equals sponge and other dot class name equals squirrel, then damage equals damage times 2 or something. They'll do something like that. Do you guys understand what I'm saying? Here's the problem. If you're going to do that, you don't need inheritance. You don't need inheritance if you're going to do that. Make everything an animal, and then just pass in as a parameter what type of animal you are. Are you a squirrel? Are you a sponge? That's it. If that's the only difference, then just say SpongeBob's a squirrel, or not a squirrel, a sponge, right? It's in the name. He's a sponge, right? And so that's the issue I have with inheritance, is that people constantly want to know what they actually are. Like they'll have a vector of animals, and you can't have a vector of animals, by the way. If you have a vector of animals, right? Let's do this. So you have a vector of animals named vec, and we say vec dot push back SpongeBob. We'll add SpongeBob to the animal vector, right? This will compile. This will work because SpongeBob is an animal. SpongeBob's a sponge. SpongeBob's are mammals somehow. Mammals are animals, so we can put SpongeBob into a vector of animals. But this is going to slice it, just as a spoiler. It's going to slice it. It's going to lose everything that makes SpongeBob special. All right. So vec dot push back Sandy, and then we will say for every animal in the vector, see out it's classic. Ooh, yeah, right. In this case, it is a sponge and a squirrel because those variables do get copied over. But if you ever do anything with these elements, they're no longer, the things in the vector are no longer sponges. They're no longer squirrels. They're animals. And so even if you use a virtual method, it won't actually call. We don't have anything special here. It's just changing the variables. The variables do get saved, but they're animals now. And so it slices them. This is going to slice sponge and squirrel to be an animal. And so if we had a function in here called for sponge called, I don't know, squeeze, yeah, sponge squeezes out water. We can say in here, if a dot class name equals sponge, then call a dot squeeze. Won't compile. Why? Because this is an animal. It's been sliced. Can't call squeeze on it. It's not a sponge anymore. So you can't actually make a vector of animals like you'd want to. You'd want to make just a vector of animals and put all these different kinds of animals in it, like it's a zoo or something. Can't do it. And so what you have to do instead is use pointers. Yeah, pointers. Pointers. Woohoo. But we still can't call squeeze on it because this is a pointer to an animal. The animal class does not have a squeeze function on it. So we have to do what's called a dynamic cast. And we're going to dynamic cast this pointer to be a sponge pointer. And if we do that, then it should work. Constant cast is a const pointer, sponge pointer. Still doesn't like that. This one is, it has to be marked as const. Fine. Good point. Good point. There. And there we go. So now if we have a vector full of pointers to animals, pointers actually will not slice things. If we use pointers instead, they do not slice. And so I know how much you guys love pointers, and because you guys use pointers so much, I think you should use inheritance. Because with inheritance comes pointers, because pointers don't slice. Because it's just pointing out a chunk of memory. It doesn't copy things into an animal. So then you can say if the class name is sponge, we can dynamic cast it to be a sponge pointer, and we can finally call squeeze on it, and will it crash? It works fine. Sponge squeezes out water. There it is. Congratulations, you have saved yourself an if statement. So dynamic cast takes place at runtime, and so we're going to be going through a bunch of animals in the animal pointers in the animal vector, and for any of them that are sponges, then we cast them to be a sponge pointer, which allows us to call squeeze on it. Or you can do what I do, which is just to make just one animal class and have a class name, which you kind of have to do anyway, and then just have an if statement. You know what I mean? You know, like it's amazing to me how much effort people will go to avoid an if statement on the class, and it's just like, and then they end up usually having to do it anyway. The whole point of inheritance is or at least virtual functions, is that it'll say if my class name is animal, call this one. If my class name is sponge, call a different one. If my class name is squirrel, call a different one. But in a lot of cases, you just have to have if statements anyway. And so I don't like all the extra overhead. Like, I used to really love it. I used to really love inheritance, and I made these giant class hierarchies and things like that. And then I realized it was just a pain in the ass. And I got burned by it too many times. Where I'd slice something accidentally, the thing would go from being a glorious sponge to a boring animal. It would lose everything that made it special about being a sponge, and then you would have to turn it into a pointer and dynamic cast the pointer into a sponge pointer, and then you could use it. And I'm just like, why the hell am I going through all this rigmarole? You know what I mean? Why am I going through this rigmarole? Just, you know, I have to have this thing anyway, so let me just write an if statement. You know? With this, I can just be like, look, with that there, I don't need to have any of the hierarchy. I can just be like, if, you know, if my class name is sponge, and the other's class name is squirrel, then, you know, oh, that's why it's not. I'm not using the damage variable. That's fine. Then damage is permanently doubled as he rages into Hulk mode. Right. I mean, if we're gonna have this, we don't need all the inheritance stuff. We just do it this way. And so I use inheritance when it stops on copying and pasting large chunks of code. But for these big, baroque, complicated class hierarchies, like I have tried it on giant 100,000 line projects, and what I have found is that they are far more pain to maintain, and they bite you in the ass far more often than they actually help you with anything. So if you just do everything in one class, you don't have to copy paste code anyway. But Kearney, what if there was a fly function? You know, like, you know, maybe we're gonna have a bird class and that inherits from animal, and only birds can fly, right? Right? You can only call that on a bird. Well, where are you going to call it? Down here? Like, for every animal, if it's a bird, call the fly function. It would be the same code if it was all animals. Like, if its class name is a bird, call the fly function. It's, you know. So if you compress this class hierarchy, sure, you're going to have one class that's going to have some weird ass stuff like this in it, fly. But I don't know. You just say, like, if my class name is not equal to bird, return something like that. I don't know. You know what I mean? And so, should fly be part of the animal class? Probably not. But like I said, I've seen people make giant class hierarchies, and they're just annoying to work with. You know, so. I you know, after working heavily in object-oriented C++ and Java, then I worked in C, and I was like, oh, actually, this way's better. Like, oh, yeah, I was basically lied to by my professor about how great inheritance is and how much time it saves you. No, it adds way too much time, and they're like, how maintainable is it? You know, it's super maintainable to do object-oriented programming. Yeah, until you need to have sponges now do double damage to birds, and so you have to make a new visitor class that will. Does it run faster if using inheritance? No, it's slower. Inheritance is slower. Because every time you have a function call, it has to do a hidden if statement to the v table. So every time you do a function call, it will secretly call the v table and say, am I actually a bird? Am I actually a mammal? Am I actually a sponge? And then if I am, call this one. If I'm not, call this one. And so every time you have a virtual, that's why it's not on by default like it is in Java. Because it slows you down. And so you have to explicitly put virtual onto a function and slow it down, because C++ defaults to being fast and dumb. Is this a pigeon? Yeah. Aren't classes when lengthy broken up into files, header and source file? Can be. Can be. You know, if you've got a giant class that does every animal in existence, it's going to be gargantuan, sure. Contrawise, if you have one file for bird.cc and bird.h and one file for squirrel.cc and squirrel.h, then you're going to have 1,000 different files in your directory, which it presents a different set of problems, right? You can't just be like, all right, where am I doing damage to sponge, right? You have to search across all your files now instead of in one place. So, yeah, coding's hard. Coding's hard. I don't hate inheritance. I used to hate inheritance. I don't anymore. It's useful. Like I showed you on the hash table assignment. It's useful. There's times where I'm like, oh, this will save me. This will be a nice, clean solution to it. What I really hate are these big, gargantuan class hierarchies that serve kind of no purpose. Like, for those things, I just compress them all into one class. If they're related. Close enough. Okay. Unity build, cancel the cow. All right, so that is it for today, guys. Your homework assignment has become C Bitfield. So there's a little bit of inheritance in here. So you've got a Bitfield class that is your basic boring Bitfield, and then the job Bitfield inherits from Bitfield, and so you don't have to rewrite these functions. Hey, cool, it's a good use for it, right? So if these functions work, you don't have to overwrite the ones that work. The ones you do need to overwrite, you overwrite, but the ones otherwise you just leave them alone. You don't have to copy paste. And you got weapon Bitfield, and weapon Bitfield should be able to inherit all three of these without changing them. The only thing you need to do with weapon Bitfield is add a function called select best weapon. So if you guys remember from last time how to set a bit, test a bit, and clear a bit, one line each, those go in there. And then those functions are done for job Bitfield, and those functions are done for weapon Bitfield. One of them you're going to have to change, you're going to override for job Bitfield. Because when you add a bit, you can't have two jobs. So if you add a new job, you have to delete the old job. So that's the twist. But you guys should be able to get this thing going and should be able to get your tests passing pretty quickly because I gave you all the code you need last time. It's 3 lines of code. Okay. Is this the last homework? It's only week 14, dude, right? Hell no. We got like a month left. It's the last major topic, but no, you guys are gonna. There's more homework. Sure. Okay, so that's it for today, guys. If you have any questions, please ask. Homework's due on Wednesday, and then again, 4 o'clock today, we're doing Irish music. Okay, should be fun. So you just put those 3 lines in the according operator. Yep. Exactly. And then those 3 lines will be in all 3 of the classes. Irish workshop is today at 4 o'clock, yes. Here on Discord in the workshops channel.